Let's do a couple percent error examples. Uh, let's look at this first one. You have a box labeled 15 ounces, and when you measure it, it only weighs 14.5 ounces. And you can figure out what your percent error is. The formula is percent error is equal to the absolute value of predicted value minus actual value over predicted value. So in our problem, the box is labeled 15 ounces. They're predicting that it's, a 15 ounce box, and you weigh it and measure the actual value, and just identifying which ones are predicted, okay, which one's the predicted value and actual value is key. Uh, and then problems, simple, simple arithmetic. 15 minus 14.5 and the absolute value of that. We do that just in case, we get something that measures a little bit higher, like 15.5. You don't have a negative percent error because of the absolute value. And it's 15 minus 14.5 divided by 15, and we're going to multiply by 100 to get it into percent form, and that's going to be our percent error. And our percent error equals 3.3% rounded to the nearest tenth. 3.3%. This is a percent sign. It's a little sloppy. All right, let's do one more. Okay, acceleration due to gravity is known to be 9.81 meters per second squared. You may not know what this unit is. It's no big deal. Let's focus on the numbers. We know this is the predicted value of acceleration due to gravity, somewhere anywhere on the planet, roughly. But when we measure it in the classroom, we get different measurements, and a student calculates and gets an acceleration due to gravity of 10.55 meters per second. So that's his measured value. That's the actual value they get in the classroom, and this is our predicted. Okay, so we got 9.81. We're going to calculate the percent error. 9.81 minus 10.55, and we're going to take the absolute value of that. Let's do that in a different color. Absolute value of that, and we're going to divide by our predicted value, the 9.81, and multiply that by 100. That's 100. So percent error is equal to this, and now we just calculate. Notice that you're going to get a negative number when you do this calculation. Again, absolute value just turns it into a positive. And your answer is 7.54%, rounded to the hundredth place. Uh, so yeah, that's really all there is to percent error.